Hello, let's consider an example on linear expansivity. A wire 20 meter long is heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. If the change in length is 0.20 meters, calculate the linear expansivity of the wire. So we have to calculate the linear expansivity of a wire that was 20 meter long, and this wire was heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. Given to us, we have the initial length of the wire to be 20 meters. Then the wire was heated from a temperature of 5 degrees Celsius, which is our initial temperature, to a final temperature of 55 degrees Celsius, so that our change in temperature will be 55 degrees Celsius minus 5 degrees Celsius. So 55 minus 5 will give us 50, and so we have 50 degrees Celsius. You will get the same answer in Kelvin, that is 50 Kelvin if you had worked in Kelvin. Okay, then from the question we are also given the change in length that has taken place to be 0.20 meters. There is a change in length because the wire expanded when the temperature increased. So the change in length that occurred after heating the wire from 5 degrees Celsius to 55 degrees Celsius is 0.20 meters. Recall that the formula for linear expansivity, which linear expansivity is what we are asked to look for, is the change in length divided by the initial length or the original length multiplied by the change in temperature. This formula can also be written as if there is a final length, then minus the initial length divided by the initial length times the temperature change. So the linear expansivity will be equals to, if we insert the values given to us, the change in length is what? 0.20 meters divided by the initial length given is 20 meters, that's the initial length of the wire, multiplied by the temperature change, which is 50 degrees Celsius. So the linear expansivity will be, if we work this out, meters will cancel meters, so we have 0.20 divided by 20 times 50 degrees Celsius will give us 1000 degrees Celsius. So the linear expansivity of the wire will be 0.0002 per degree Celsius, or you can also decide to write it as 0.0002 per Kelvin. So the final answer, that is the linear expansivity of the wire, is 0.0002 per degree Celsius, or 0.0002 per Kelvin. I hope you understand this example. Here's another example on linear expansivity. An iron rod of length 50 meters and at temperature of 60 degrees Celsius is heated to 70 degrees Celsius. Calculate its new length. Linear expansivity of iron is 1.2 times 10 to the power minus 5 per Kelvin. So we want to calculate the new length of a rod after it expanded. The initial length of the rod is 50 meters at an initial temperature of 60 degrees Celsius. The temperature increased from 60 degrees Celsius to a final temperature of 70 degrees Celsius. So the change in temperature will be the final temperature minus the initial temperature, and that will be 70 degrees Celsius minus 60 degrees Celsius. And that will give us what? 10 degrees Celsius, which can also be in Kelvin since we are talking about change in temperature. Okay, then the linear expansivity of iron given to us is 1.2 times 10 raised to the power minus 5 per Kelvin. Recall that the formula for linear expansivity is the change in length or the increase in length over the initial length multiplied by the change in temperature. We are looking for the new length, which is L2. So if you make change in length separate to the formula, you're going to have L2 minus L1 equals to the linear expansivity multiplied by L1 multiplied by the change in temperature. If we insert the values, since we are looking for L2, we write L2 then minus 50 meters equals to the linear expansivity, which is 1.2 times 10 raised to the power minus 5, then multiplied by 50 meters again, that's the initial length, then multiplied by our temperature change, which can be 10 degrees Celsius, but this time I'm going to work in Kelvin because the linear expansivity of iron is given in per Kelvin. Okay, I said it earlier that the change in temperature in degrees Celsius is the same thing as the change in temperature in Kelvin, so I'm working in Kelvin. So if you continue, you are going to have the linear expansivity minus, the final length or the new length minus 50 meters equals, if you get your calculator and you do the right hand side, you have 1.2 times 10 is power minus 5 times 50 times 10. I hope you are doing it. So you are going to get 0.006 meters. Reason is because there is a per Kelvin here. I forgot to add that, so let me just see before we're putting that. Okay, there's a per Kelvin here, so if you multiply per Kelvin and Kelvin, you are going to get 1, so meters will be left. So the final or the new length of the iron rod after it expanded will be 0.006 meters plus 50 meters. So you are going to have 50.006 meters. That will be the new length of the iron rod that we have been asked to look for. I hope you understand this example. Here is one more example on linear expansivity. A rod of initial length 2 meters at a temperature of 25 degrees Celsius is heated to 80 degrees Celsius. Calculate the increase in length of the rod if its linear expansivity is 0.004 per Kelvin. Okay, so we want to calculate the increase in length that occurred in a rod after it expanded. Given to us from the question, we have the initial length of the rod to be 2 meters, and the rod's temperature increased from an initial temperature of 25 degrees Celsius to a final temperature of 80 degrees Celsius. And we were given that the linear expansivity of the rod is 0.004 per Kelvin. Okay, so we are looking for the increase in length or the change in length. We don't know what it is. So we are looking for the increase in length or the change in length. The formula for linear expansivity is the change in length divided by the initial length multiplied by the change in temperature. So if we make increase in length, that's this, or the change in length, if we make it the subject, we are going to have change in length will be equals to the linear expansivity multiplied by the initial length multiplied by the change in temperature. So the change in length or the increase in length will be 0.004 per Kelvin multiplied by, what is the initial length? 2 meters given to us from the question. Then multiplied by the temperature change will be 80 degrees Celsius, which is the final temperature, minus the initial temperature. Okay, so the change in length will be equals to 0.004 per Kelvin times 2 meters, then multiplied by 80 minus 25 will give us 55. It is safe if I put Kelvin here. Now, the change in temperature when you're working in degrees Celsius is the same as the change in temperature when you're working in Kelvin. So I'm going to be working in Kelvin because of the Kelvin I have here. Okay, so it's the same. You can try that, meaning you can change 80 degrees Celsius to Kelvin. You can change 25 degrees Celsius to Kelvin. If you subtract, you are still going to get 55. So it doesn't matter whether you work in degrees Celsius or you work in Kelvin. But note, 1 degree Celsius is not the same thing as 1 Kelvin. It is only when we talk about the change in temperature, that is when you can interchange the units. So the change in length or the increase in length will be, if you use your calculator, you have 0.004 multiplied by 2 multiplied by 55. And so you are going to get 0.44 meters. Simply because the Kelvin here and the per Kelvin here will cancel each other. That is 1 over Kelvin, that's per Kelvin, multiplied by Kelvin. Kelvin will cancel Kelvin, so meters will be left. So the increase in length of the rod will be 0.44 meters. I hope you understand this example. Thank you for watching.